Let's look at classifying the critical points for this function. Now, if you've been practicing some, you may want to go ahead and do this. Find the partials while I'm also doing it to see if you've got that procedure down. I would first start this by writing it as xy plus 4 times x to the minus 1 plus 2y to the minus 1. And why do we do this? Because for integration or differentiation, which is what we're doing, differentiation, but the same is true, we must have powers in order to differentiate. Let's go ahead now and take our partials, because maximum and minimum always require derivatives. So I'm going to go ahead and find the partials with respect to x. First term has an x, and the second term has an x. So the first term is y, because the only thing that matters is the x. That leaves over the y, so I copy it. Now moving along, I have minus 4, x to the minus 2. The next term has no x's, so its derivative is 0. Now I'll find the second derivative of f with respect to x, and that is going to be the derivative of y will be 0 since there's no x, and now I have 8x to the minus 3. For the derivative of f with respect to y, the first term, now all I care about is the y. The x just follows along. I just copy it. The derivative of y is 1. Next term has no y, so it's 0. And now I have minus 2y to the minus 2. The second partial then of f with respect to with respect to y, will be, the derivative of x will be 0. Then I have 4y to the minus 3. The other second derivative I will need in order to find max and minimum will be the second partial of f, first with respect to x, then with respect to y. So this will be the partial with respect to y of y minus 4x to the minus 2. With respect to y, that'll be the derivative of the first term, which is 1. Now we're set to find our critical points. For that, we will be using just the first partials, and we'll be setting them equal to 0 and solving it. So I have y minus 4 over x squared equals 0. Now I convert my negative exponents into fractions because for myself, it's easier to solve. I can multiply by x squared to get rid of the denominators. This gives me yx squared minus 4 equals 0. So I get yx squared equals 4. And solving for the easiest one, I would have that y is equal to 4 over x squared. Now let's solve the second one, which would be the partial of f with respect to y. Let's set it equal to 0. Oops, I didn't change it, did I? So, it's possible to do it without changing it, but I think it's usually easier to change it to a fraction. Equals 0. Now I'm going to multiply by y squared. I'm multiplying each term by y squared. So this gives me xy squared minus 2 equals 0. I solve for x because that's the easiest one. Always choose the easiest one. And this then equals 2 over y squared. Now I've solved, so now I can substitute. So I'll substitute this one in here. That will then give me that y is equal to 4 over 2 over y squared squared. Well, that's 4 over y to the 4th. Now I take this fraction that's in the denominator and flip it. So this gives me 4 over 1 times y to the 4th over 4. And that's equal to y. So my result is that y is equal to y to the 4th, because the 4's over here cancel. Now we never divide, so I have y to the 4th minus y equals 0. I always factor. Y cubed minus 1 equals 0. This gives me y equals 0. y cubed equals 1, so y equals 1. When you have a y cubed, that does not equal plus or minus. Only your even number powers give you plus or minus. Now that I have a y value, I can plug it back in where I started when I substituted. So at y equals 0, x equals 2 over y, which would be 0. Can we have that? No. So this cannot be a critical point. Now at y equal 1, x is equal to 2 over 1, which is 2. So we have one critical point of 2, 1. Now we want to use our D criteria in order to classify this as a max-min saddle point or no information, not enough information. Now we will use D in order to classify this critical point as a maximum, minimum, saddle point, or not enough information. Writing down what D is equal to, we use our second partials. So it's 8x to the minus 3 times 4y to the minus 3 minus this last second partial, minus 1 squared. So now at the point 2, 1, we calculate D. So D is equal to 8 times 1 over 2 cubed, which is 1 over 8, times 4. Y is 1, so that stays 4 minus 1. So I have that D is equal to 3, which is greater than 0. Now I have to determine if this is a maximum or a minimum. Remember that having D greater than 0, you have to do one more test. I have to look at the second partial of f with respect to x and determine if that is positive or negative. I always remember this rule by saying, oh, I care most about x's, haven't we always? So that's the second partial I'm going to look at. That is equal to 8x to the minus 3. At x equals 2, that's going to be greater than 0. It's going to be 1, which is greater than 0. That means it's concave up. I have a minimum. So we have classified this critical point as a minimum, and you are done.